I used to say things like, well, I was just born with a slow metabolism. Is there any validity to this claim?
It's not that a slow metabolism that you're born with causes you to grow body fat and gain weight. It's the other way around. Excess body fat and gaining weight crushes your metabolism.
Welcome to Commune. We are on a mission to inspire, heal, and bring the world closer together. Dr. William Lee, great to be with you. Welcome to the Commune podcast.
Thanks for having me, Jeff.
Yeah, so I just want to begin on a personal note. So last time you were on the show, we discussed your last book, which was called Eat to Beat Disease, where you explore how eating certain foods can activate the body's 5 health defense systems to fight disease, including cancer. So my dad has been in a bout with cancer, and he's 81. And, you know, a lot of the information that you presented in that book was just simply not available and not highly researched, you know, when he was in his adulthood. Mm-hmm. And, well, I guess I'll say I never thought my dad would be drinking as much green tea and eating as many mushrooms as he's eating because I prevailed upon him to get the book. And he's really administered a lot of the protocols in the book, and he's doing great. And but he really feels a greater sense of agency over his own health, and that's just so important. And it's been a very big personal part of my life and my relationship with him. So just thank you for your work. I appreciate that.
Sorry to hear he has cancer, but I'm glad to hear. That's the whole point about food. There's an immediacy to it. You can act on it, and it does give you agency over your own health in a way that relying on a health system around you cannot.
Yeah, absolutely. And obviously, you know, he's in the health system, and he's you know, balancing a whole variety of different protocols.
Sure.
And I think you're wonderful in that way. You're very open-minded. I think you see a lot of the better attributes in the better parts of modern Western allopathic medicine. And then that has to be balanced.
Right.
And you do a wonderful job of the middle way, what I call as a Buddhist reference. So, you know, one of the things that I found interesting, and you mentioned this in the early parts of your new book, Eat to Beat Your Diet, is that you got a lot of messages from people that were applying the dietary principles that help fight disease, but they were also saying that these same foods and same protocols were helping them burn fat and improve their overall metabolic health, which I'm sure this was a big light bulb for you as you were approaching, you know, this book. So maybe we could start with talking about fat and the nature of fat and what are the different kinds of body fat and, you know, which type is more detrimental to health and are there health promoting fat? So let's start there.
Yeah, well, look, the journey of my new book, Eat to Beat Your Diet, really started at the end of my first book because I was really, you know, as a researcher, continuing to study how the body's hardwired for health. And it goes without saying that our metabolism is actually very important. So my research had actually moved into the metabolic area where people were interested, and I was interested in really uncovering what are the secrets of metabolism? What do we not know, not yet know yet? And what do we need to do more research on? Well, as you mentioned, I started getting these emails that were happening at the same time that I was working on my research on metabolism. And from my last book, I had been very conscious that I was telling people to eat wonderful foods, these incredible ingredients. And in the back of my mind, after my first book, I thought, maybe if people were avidly eating these foods, they would also gain weight. And that was always a kind of a secret concern after my book was launched. I thought, you know, I don't want to contribute to the obesity epidemic. But the feedback I got was just the opposite. And because I'm a scientist, I'm trained to actually be attuned, like exquisitely attuned to when I see something or I hear about something that's unexpected. So people that were eating foods that I had recommended in Eat to Beat Disease were actually telling me they were feeling healthier, but they were also losing weight in ways they couldn't lose when they tried before. Eating food should make you gain weight. Eating foods shouldn't make you lose weight. And so that actually converged my research on metabolism to say what could be going on. So this next book, Eat to Beat Your Diet, is all about, it's a reveal, a big reveal of all the astounding new discoveries on metabolism and body fat and the foods that can actually help us improve our metabolism without trying very hard. That's the key thing. Diets take an effort, and that's why oftentimes we don't stick to them. They are about elimination, restriction. There's a value judgment to why you're on a diet. And one of the things that I discovered and I share in this new book is really the fact that our body is hardwired to run its metabolism in an optimal sort of way. And that body fat is not an enemy. Body fat is actually a friendly force that we're born with. And it's actually incredibly important for our health until you have too much of it. And finally, the discovery is that eating foods actually can ramp up your metabolism in ways that we had never thought of before. And it's not just simply the kinds of claims that you hear on the advertisements by the weightlifting group community or bodybuilding group, but in fact, metabolism has been studied in human research and actually been shown to be activated by specific food ingredients. So let's take it from the beginning about the things that we're learning about body fat. All of us associate body fat with kind of there's negative connotations to the word fat, right? All of us, myself included, have had this experience where you step out of the shower in the morning, you glance in the mirror from the corner of your eye, and you see yourself, and you see a lump or a bump that you don't want to be there, and so you immediately begin associating, well, I have that piece of myself that I'm not happy with. And then you step on the scale, and the number that comes up may not be the number that you actually want to see. And so right from the get-go, as adults, we associate body fat with something that's kind of negative. However, body fat is actually something that starts at the beginning of life, and it's very pleasing. I mean, think about it. A healthy baby that makes everyone smile is a chubby baby with big fat cheeks, fat arms and legs, just like like one of those balloons that clowns make at the circus, big, and they've got a big belly, right? And as a scientist, I went and dug back. Where does body fat begin? And it turns out your body fat started developing in the womb. Okay, in fact, it started to develop before you had a face you could stuff with food. So here's what happens: your mom's egg meets your dad's sperm. Okay, and then there's a ball of cells that started to form the future you. First tissue that gets laid down is your circulation, blood vessels, because every organ needs a circulation. Second tissue that gets laid down are nerves. That's because every organ needs signals, instructions on what to do. The third tissue that gets laid down is fat cells. These are little tiny fat cells. They're tiny. And they wrap themselves around blood vessels like bubble wrap. All right? Now, why is that? Because fat cells actually are our fuel tanks, and we get fuel through our blood vessels for our future selves, and the fat cells get loaded up with the fuel, and that's really how we operate our metabolism. And so when we're born, we are actually packaged like a car rolling off the assembly line, ready to actually be taken for a drive. And the idea of metabolism is exactly relevant to how we actually drive a car. Our metabolism, very simply put, is how our body uses fuel to run the engine of our body. The same way that we use gasoline, for those of us who drive a gas car, or electricity, for an electric vehicle. The car runs on fuel to run its engine to go from point A to point B. That's how our body is. Our metabolism is simply taking the fuel to run our body's engine. Our fuel, not coming from a gas station. Car, you're driving in it, you look at the fuel tank, the fuel gauge runs low. What do? You pull over to the filling station and you put the nozzle in the tank and you fill it up until it clicks, and then you drive off. For us, our body's engine, our metabolism senses the fuel tank is running low. So we don't go to the gas station. We pull over to the kitchen table, to the refrigerator, to the pantry, to the restaurant to grab some food. Our food is our fuel. That's, very simply put, how our metabolism actually works. Now, when we actually eat food, we absorb that energy, the fuel, into our bloodstream. And what happens is our body, aided by insulin, takes in that energy, uses it to power our bodies, and anything extra gets stored into the fuel tank, the fat that started in the womb. So it just gets loaded in there, all right? Now, what happens is that then we are able to stop eating, and we drive off until the fuel tank runs low again, and then we got to reload, just like in a car. The amazing thing is that the way that our metabolism actually runs is designed, hardwired to be perfectly engineered for an entire lifetime. You know, people talk a lot about longevity now, healthy aging, all right? And our metabolism is also hardwired in us so that we can actually go our entire life in an optimal energy sort of way. So that's the kind of the beginning of the story, and then the real surprises happen once you dig in.
Okay, well, that was an amazing explanation of metabolism. And, fat serves many positive purposes, right? It gets derided as this thing that we don't like to see in the mirror, as you say, but it's a fuel tank, and essentially, and it's used for, for shortages. And, we used to experience, as a product of our existence, these periods of abundance and then these periods of scarcity. The problem is, in the modern Western world, we don't experience as much scarcity. Now, that's not true everywhere, and I don't want to overgeneralize, but what we're dealing with often with a standard American diet is overnutrition or overabundance, where we never actually run through the fuel tank. We just keep building the fuel tank up and up. And so maybe you could go into, what are some of the detrimental knock-on impacts of the accumulation of excessive fat?
Yeah, no, that's a really important point. So let's go back to that car analogy. You're driving your car, fuel tank's low, you go to the gas station, you put in a nozzle, fill up the tank. Nozzles at gas stations are actually engineered so that there's a click when the tank is full, and you know that no more gas is going to come out, so you put it away and drive off. Our body is wired to have a click. So when we pull over to our dinner table and we start putting fuel in our body, food equals fuel. The fuel has a name called calories, but I don't want people to get fixated on calories in, calories out, counting calories. I want to think about fuel. That fuel actually goes to our body. Our insulin basically says, let's use all the energy we need to run the body, but let's store anything that's extra for later. It loads it right into the blood, from our blood vessels into our fat cells, that bubble wrap, okay? Little fat cell actually gets a little bigger. It loads up with the fat. Like a fat cell can get loaded up 100 times larger than how it starts out. So it's got enormous capacity. It's like a balloon you can really blow up really big. And when we stop eating, all right, we stop loading up on fuel, and then we start burning it down. But let's say we keep eating because we don't actually have that click, all right? Now, if the clicker on the gas nozzle were broken, what would happen? The gas tank would fill up, it would overflow, it'd run down the side of the car, run around the tires, pool around your shoes, and we'd be standing in a dangerous, toxic, flammable mess. And we would have to step out of it, and air would have to evaporate all the fuel to avert a disaster. Okay. Now our body, when we overload with food, We keep on eating. There's no clicker. So we overeat and we keep on loading up the fat cells. It gets 100 times bigger than it was. And then, but we're still loading in food. Now the body has to produce another fat cell and load it up so it gets really big. Oh, we still have more fuel coming in, so it makes another one. And you can kind of see how the fat that we were born with starts to expand because we are just putting more fuel in the tank. Our body creates more fuel tanks. Now, as the fuel tanks, i.e. fat, starts to build up bigger and bigger and bigger and bigger and bigger. The problem is fat kind of grows like a tumor, meaning that as it expands, it needs a bigger blood supply just to stay alive. And when you actually grow faster, when the fat grows faster than the blood supply can be recruited, the center of the fat starts to die. It doesn't have enough oxygen. We call it hypoxia. And when in a hypoxic center of fat, it's like a hypoxic center of cancer, it becomes very inflammatory. And then what happens is that inflammation basically seeps out of the fat and goes everywhere in your body. And now you've got this leaking inflammatory mess. And by the way, the fuel itself can leak out of the fat when it's too full. When the tanks are completely jammed, the fuel leaks out. And you know what it builds up? It builds up in your liver, and you can have non-alcoholic fatty liver disease, which is an epidemic in itself in this age of abundance and overeating.
Yeah, and it contributes to further insulin resistance, right? So what you get on is this kind of treadmill.
Yeah, that's right.
That is detrimental in every way, and so when we get out of the shower, for example, you use that and we look at, like, let's say, accumulation of fat, like around our thighs or something, in our lower torso, for example. What kind of fat is that? And is that the most dangerous fat that we should be worried about?
Yeah. So there's a whole new science about fat that teaches us what fat itself does for us. It's a fuel tank, stores energy. It's a cushion, right? So in fact, if we didn't have fat in our body, if we slipped on a rug and fell on the floor, our organs would burst like a water balloon. So it's a cushion. The third thing is it's an endocrine organ. Now, this is the big surprise to some people, is that fat is an organ like our heart, our kidneys, our pancreas, our spleen. It's an organ, and it's not just any organ, it's an endocrine organ, which means that fat releases hormones. We know 13 organs at least are made by our fat. Surprised? Yeah, and not only does fat secrete an organ, but the hormones, fat is an organ that secretes hormones, but the hormones that are secreted actually control our normal healthy metabolism, including insulin. So here are some organs, fat hormones that you may or may not recognize. First one is called leptin. Many people have heard of leptin. It controls your appetite. You have more leptin, you have less appetite. It's kind of like the volume switch that makes your brain more or less hungry. Okay, people have heard about that. But here's a hormone that you haven't heard about probably, and it's called adiponectin. Adipo, meaning it comes from a hormone that comes from fat. Adiponectin is actually made by fat. It's all over our bloodstream. And in fact, Jeff, if I drew a vial of blood from you and sent it to a regular hospital lab to measure your hormones, adiponectin would be 1,000 times higher in this blood level, in your blood level, and in mine, than any other hormone in our body. Higher than thyroid, higher than testosterone, higher than anything. What does adiponectin do? Why is it so high? Because adiponectin allows insulin to draw the energy into our cells. Without adiponectin, insulin's not going to work very well. You're resistant to the effects of the insulin drawing energy. And then the third hormone that I want to tell you about is called resistin. Resistin, basically, if adiponectin is a gas pedal, resistin is the brake. And so the brake, resistin, actually just counters. It allows you to kind of steer the ship. So a little bit this way, a little bit that way, so you can regulate your energy. It makes perfect sense. Now, there are many other hormones that, we don't have time to talk about, but here's the thing. When we grow too much excess body fat and it becomes inflamed, that inflammation that excess leaking fat, energy, destroys the hormonal properties of our healthy fat. Now leptin is off the grid. So are you hungry or not hungry? Your brain doesn't know. Adiponectin crashes. Now your insulin doesn't work so well, so you can't actually draw the energy in as well as before. Resistin, it's off the charts. So are you putting on the brake or are you putting on the gas pedal? Nobody knows. And this is why excess fat basically wreaks havoc in your body.
Yeah, that's so well explained. And, it's also logical. If you have too much leptin in your system, your brain will eventually become resistant
Numb.
to the leptin, right?
Yeah.
So it won't know if you're, reach that level of satiety or not. So it stops being effective.
Right.
And then leptin is also very associated with immune function, right? It has a relationship with T cells and the ability to develop like healthy antibodies with B cells and stuff like that. Can you talk just a little bit about the relationship with the immune system?
Yeah, I mean, all of these fat hormones are connected in one way, shape, or form with our other body's health defenses, with our circulation, with our immune system, even with our gut health, actually. It turns out the leptin and our gut health are interconnected. So when you have and by the way, like most hormonal signals, too much is not good, too little isn't good. You want just the right amount at the right time to be able to do its thing, all right? And so what happens is that leptin is a regulator of our immune system. And by the way, do you know why? It's because about 20% of our immune system is actually found in our body fat, healthy body fat, okay? Normal, healthy immunity, not inflammation. Inflammation can be triggered. When the fat's growing too big, it'll die in the middle and it'll become inflamed. But our normal, healthy immune cells basically are like jets parked on a aircraft carrier, about 20% of them. Most of the other immune system is parked in your gut, in the wall of your gut, right? So we know that gut health is important to immunity. It turns out that fat health is also important to have the right amount of fat to allow our immune system to function. Leptin, which is produced by fat, also helps to control your immune function. You don't want to have too much, you don't want to have too little, and your immune system, the planes won't fly off the carrier at the right time.
Yeah, so when we're talking about detrimental adipocytes, are we talking about the fat that you can see that's right under the skin, otherwise known as subcutaneous? Or is there a more hidden fat in our viscera that is more, dangerous as it pertains to, to some of these things we're talking about, like inflammation?
100%. And so the new Science of Fat also tells us, it's sort of, there's a kind of a new organization of understanding body fat. I like to explain it this way. Our fat comes in two colors. We've got brown fat, which is a good kind of fat, and we've got white fat, which usually is good, but it could be bad. All right, brown fat's almost always good, but white fat, when you have the right amount, it's fine. If you have too much or too little, it's not good. All right, so what is then if you take a look at those, white fat comes in two different flavors. One is subcutaneous. Subcutaneous means under the skin. That's a lumpy, bumpy, jiggly stuff. It's under your arm, under your chin. It's the muffin top. It's around your thighs and your butt, okay? And by the way, I just want to point out, when properly placed in the right amounts, okay, subcutaneous fat makes the body beautiful. All right, so let's always remember that when it's too much, we can see it. All right, but that's not the most dangerous fat. The most dangerous fat is another kind of white fat. It's called visceral fat, as you talked about, or VAT, V-A-T, visceral adipose tissue. And visceral fat is exactly what its namesake says it is. Viscera is guts. Visceral fat is fat around the gut. So think about, it's not under the surface. You can't see it. It's packed inside the tube of your body. And it doesn't matter if you're a big-bodied person or a small, thin-bodied person, you can still have too much visceral fat, which is why skinny people need to watch out about this kind of harmful fat, potentially harmful fat as well. Now, how do I think about visceral fat? Visceral fat is like a baseball glove at its worst, wrapped around your organs, choking your organs, becoming inflamed. All right. I mean, and literally it completely envelopes your organs and it chokes them. Now, it doesn't start out that way. It starts out like smaller pieces doing its thing, releasing its hormones, cushioning, doing all the things that you want it to do in a healthy way. And I tell people, like when people say, I'm in the midst of fat, oh, I don't need to worry about body fat. I'm really thin. Wrong. You can have a thin frame, but you could have a lot of visceral fat. You might not have a lot of subcutaneous fat. You might be a lot jiggling. You might not have a muffin top, but inside your body could be this dangerous baseball glove of fat choking your organs. Now, here's how it works. Imagine if you were shipping some champagne glasses across the country. You go to Federal Express and you get a long, thin box to ship the glasses. All right? What are you going to do? You're going to ask for some packing peanuts, and you're going to pour those packing peanuts in and lay the glasses in there. Now, you could easily just close it once you put just enough peanuts in, or you can keep stuffing peanuts into that box. All right? And then what you do, it's like bursting with peanuts. All right? And it's pressing on the champagne glass. All right? And then you're going to force the lid shut. You're going to tape it shut. At arm's length, it's still a skinny mailing box. But inside, it's bursting at the seams with fat. That is what can happen to anybody, large body, small body, if you have too much visceral fat. And remember, that visceral fat, when it's inflamed, is extraordinarily dangerous. That is the fat that leads to metabolic syndrome, diabetes, cardiovascular disease, sets you up for cancer, probably sets you up for neurodegenerative diseases as well, including Alzheimer's. So that's a second kind of fat that when it's good, but when it's bad, it's really, really bad. And so brown fat is subcutaneous versus visceral. I know it's a lot to keep track of, but the idea is really that there's stuff you can see and there's stuff you can't see. The stuff you can't see could be more dangerous than what you see in the mirror in the morning when you step out of the shower.
Yeah, I had Robert Lustig on the podcast maybe last year, and I think he gave me the acronym TOFI, thin on the outside, fat on the inside, and it sounds like that's what we need. Like even slim people can have visceral fat and suffer from some of these downstream diseases that are associated with it. Let's talk about brown fat for a second, because I feel like brown fat is having its moment.
Can I tell you one? Yeah. I want to say one more thing, because I think the viewers and listeners are going to want to know about this. All right, visceral fat is not just in our guts; it's actually along our entire digestive system. And so, one of the questions that I ask people when I'm teaching about this is, where do you think when you gain visceral fat, dangerous fat, where do you think is the first place it accumulates? Like where do you think it's in your belly? Where do you think, Jeff, the first place it accumulates?
Just instinct.
Yeah.
My gut instinct would say my gut.
Right. And because most people can see it. But I can tell you one of the first places you accumulate body fat, excess body fat, is not around your waistline. It's actually in your tongue. Your tongue can get fat. And here's why. And this has been studied by pathologists studying the anatomy of the tongue. Tongue has got three parts to it. The first tip of the tongue is like a Cirque du Soleil acrobat. It can do amazing things. The second part of the tongue is a muscle, very strong muscle that can actually move food around your mouth. The last third of your tongue actually is kind of a lumpy, bumpy pillow. It is marbled with fat like a ribeye steak. All right? And so when we actually gain visceral fat, the marbling increases. Now, how do we know this happens? We know this happens in skinny people because oftentimes their bed partner says, hey, you started snoring. You never used to snore. And what's happening is that when you ask them, they're actually gaining weight at the same time. They're actually gaining some body fat. And what's actually happening is that when they're sleeping, they're relaxed. And their fat tongue is also relaxed, and it's slipped down and it blocks your airway. So it winds up causing sleep apnea, obstructing your airways. You start snoring and not getting very quality sleep. That's one of the first places that you can actually start gaining visceral fat in your body.
God. So excess fat isn't only associated with cardiovascular health and cancer and diabetes. It's also associated with sleep apnea Because it can make your tongue fat. That's crazy.
In women, it can. I mean, this is the research study been done. It happens in women and men, but the research studies have shown this dramatically in women and in thin women. That's the key thing. Like it can actually happen to skinny people. So that's, let's talk about brown fat. But I just wanted to make the final that point really that what's amazing is our fat is so important for our metabolism until we go over the line. And this whole idea of abundance and overloading our fuel, taking in too much fuel at the filling station, our dinner table, that's actually the setup for the dangerous accumulation of fat.
Yeah, so important. What we're really looking for is to align with our adaptive mechanisms, and unfortunately, culture, which is expressed in processed foods and portion size, has essentially hijacked our adaptive mechanisms and made them maladaptive. Like, we are actually designed to store a certain amount of fat for the very reasons that you so eloquently articulated. But when we misalign with our brilliant evolution and intelligence that's in here, that's when we seem to get into bigger trouble.
That's right.
And so brown fat. I'm an avid cold therapy guy. So ice baths and more cold showers, etc. So I was first introduced to brown fat through the concept of thermoneogenesis, essentially making my body very cold and then having to basically jumpstart it and move my body temperature up into that little 98.6 Goldilocks zone. So that was my first introduction to brown fat. But this is one of the beneficial fats, right? So can you maybe unpack, if you will, brown fat a little bit? Like, where is it located, and how does it function, and what are some of the foods, for example, that can stimulate thermoneogenesis and brown fat? And can you actually turn white fat brown?
Okay. I think the best way to bring everybody into the story is to tell the story of brown fat. Okay, in the 17th century, there was a scientist, a naturalist. He studied the natural world. He was observing animals and plants and trees, named Conrad Gessner. And he was actually studying a little critter, a rodent called the alpine marmot. It's kind of like a groundhog, kind of a big squirrel that would hibernate, because the mountains in Switzerland and in Europe are actually quite cold in the winter. And he would catch one of these things and say, well, I wonder what's inside it. So back in the day, people were dissecting and drawing the organs they were seeing. And what he found in these alpine marmots, particularly ones that were hibernating, he saw this brown tissue that he thought was an organ, but he couldn't identify it, sitting between their shoulder blades. Okay, and he actually did know what it was, but he thought it was kind of it's kind of fatty, little jelly fatty thing. And after he discovered this and started publishing on it and teaching about it, other scientists started to see, the same thing is in other hibernating animals, bats, squirrels, a number of other hibernating creatures also had this little lump. They didn't know what it was. All right. In fact, they called it a hibernoma because it was a little mass that was associated with hibernating animals. Right. Fast forward at UCLA. This was actually in the 1900s. There was a physiologist, somebody who studies healthy body function, that actually looked under the microscope, because at that point the techniques of looking under the microscope were becoming very sophisticated, and said, wait a minute, that is fat. It is a kind of adipose tissue, but it's brown. Now, why is it brown? It turns out that this fat, connecting to the hibernation story, was generating energy to keep the hibernating animals warm in the winter. All right. And where was it drawing down? Where was it getting the fuel to run this space heater? It was drawing down on the other fat. So this brown lumpy fat was drawing down on the other fat that the animal had accumulated while they were eating up, ready for the winter, burning up and creating heat. Why was it brown? It turns out that the energy generating part of brown fat is a tiny little function in a cell called a mitochondria. Now, when I was actually in medical school, I used to remember that from my test by calling it mitochondria. Okay, it's like a little tiny nuclear battery. All right, it fires up and it creates a ton of heat. It creates energy in a cell, and it turns out the mitochondria has a lot of iron in it. Iron is brown under the microscope. And so a lot of iron, a lot of mitochondria is a lot of iron in brown fat. That's what makes the color brown. All right. So this is like how the scientists start to peel back the layers of the onion, so to speak, or the brown fat to figure out what it is. All right. Fast forward. They're like, okay, well, maybe do humans have it? We found it in babies. All right. Babies had it right between their shoulder blades, little for maybe a year or so after they're born, and then it seems to kind of go away. And so what researchers, a medical researcher said, yeah, it's in one of those vestigial organs like the appendix or the tonsils. We don't need it anymore. Well, of course, we now know the appendix and the tonsils are absolutely critical for holding our gut microbiome for gut health and our immune system. So, but back then we were just kind of discarding. Researchers were like, I don't know, probably means nothing. And so zip that fast forward to the 1990s. All right. And even beyond. People were saying, let's go see if there's any brown fat around. And what they were finding, and this was really the seminal research to discover brown fat is actually, there's a lot of brown fat in adults, but it's hidden, is that there was a woman that came into a hospital in Boston that had a tumor by an x-ray in her chest. And so right around then, there was something called a PET scan, positron emission tomography, PET scan, PET, that would capture metabolism. Right, that's cool. X-ray captures a black and white picture. CT scan gets slices. MRI gets more detailed in the slices. PET scan just gives you metabolism. What a cool way of imaging. So this woman, they thought she had cancer, so they actually tried a PET scan on her along with the CT scan. And what they found was surprising. They found that this little tumor that she had lit up like a Christmas tree. It was highly metabolically active. So they biopsied it. And when they biopsied it, looking under the microscope, what they found was surprising. It wasn't a cancer at all. It was a mound of brown fat that had grown in her body. And they found it on a PET scan. So the researcher goes, wait a minute, what's it doing there? This is an adult with brown fat. So the researcher, Ronald Kahn, went back and looked at 1,000 PET scans of other patients who had the same kind of scan, PET scan, at the hospital. Like basically imagine going to the radiology department and pulling out all these scans one by one and just like looking through them. Is there any brown fat? Is there any brown fat? What's there? And what he found, in fact, there was brown fat. Not in everybody, but in a lot of people. That was just missed. It was hidden in plain sight. And I'm going to get to your cold temperature therapy in a second. What he did is he then looked at the irregularity is when you could see the brown fat, and then he went back to the weather forecast on the day that those PET scans were taken. And what he found is that during warm weather days, you hardly saw the brown fat by PET scanning. But in the winter in New England, when it's freezing cold, that's when the PET scans lit up with this brown fat. And where do they find it? They found it around the neck, under the chest, under the arms like a bra strap, a little bit behind the back, not too much, and a little bit in your belly. And cold temperatures would fire up this brown fat just like you expect. We find this, by the way, in people who work outdoors, like people who work on telephone lines and lumberjacks. Their brown fat lights up. Like we know this in the Nordic countries now. Outdoor workers in cold temperatures, they got a lot of brown fat. But the real surprise is that not just temperature, cold temperature, but certain foods, when you eat them, can also light up brown fat. Meaning, not only does cold weather fire up your metabolism through brown fat, and don't forget that brown fat has to draw that fuel from someplace, and it draws it from harmful white fat, subcutaneous fat, and visceral fat. Turns out foods can do the same thing. So back to the observation I had from my first book, Eat to Beat Disease. Wow, this was like my eureka moment. Foods contain natural substances that activate your brown fat. You can literally eat to improve your metabolism. You don't gain fat, you lose it.
That is an unbelievable story. In the book, Eat to Beat Your Diet, talk a little bit about what's called beiging, essentially turning white fat brown, which of course makes sense from a color spectrum perspective. And in your first book, you talk a lot about regeneration and stem cells, for example. So through the consumption of certain foods, you can actually stimulate stem cells. They can be directed to actually create more brown fat. Is that right? And then actually beige the more odious and detrimental white fat. Is that a fair understanding?
Yeah. Well, let me kind of lay it out. So when we're born, we all have about 70 million extra stem cells that we didn't need to create our bodies while we were in our mom's womb. The 70 million stem cells get packed everywhere. They get packed in our bone marrow, in our skin, some in our heart, but a lot of it gets packed into our fat. So our fat is a reservoir of regenerative stem cells. Another important function, it's a suitcase. It's a carry-on of stem cells, and we need those stem cells to do a lot of things. One thing we need them for, by the way, we already mentioned this, if you actually fill up extra in your gas tank when you're overeating, remember I told you, if you fill up one fat cell, now you got to make another one. That's where your body calls in that stem cell to create another white fat cell to load up on the fuel. And yet another one, and yet another one, and now you're growing it up. So our stem cells in our fat, called adipose stromal cells, ASCs, okay, they're very, very important. They help us. They give us capacity to store fuel if we need it. They're both our friend, but they're our foe if we actually overeat, as an example. Now, I want to tell you, as a researcher, I've been involved with regenerative medicine on the biotech side for some years. These adipose stromal cells, we really need to sit up and respect them. They are so powerful. And by the way, it tells you about how powerful they can be in fat, that biotechnology folks, and I've been involved with this, are doing liposuction, removing fat from people, and taking out the stem cells. All right, here's how we do it. You pull out a jar of fat from suction, like a plastic surgeon does, and you add a little bit of enzyme to it. It digests the fat, separates the fat. Now you put it in a centrifuge. It goes round and around and around and around. The cells go to the bottom of the tube. The fat floats to the top. You stop the machine. You take the tube. You pour out the fat, and now the stem cells are at the bottom. What's amazing, and this is what we've been doing, you can take those stem cells, the plastic surgeon can take those stem cells, and you can hand them to a cardiologist and give it to a heart doctor to load up, who would then snake it up and inject those fat stem cells into your heart. Now, these stem cells will pay attention to whatever environment they're in. So when they're in body fat, visceral fat, subcutaneous fat, they'll make more. When you inject them into the heart, guess what? They make more heart cells. They make more blood vessels for your heart. So they're context dependent.
So they're pluripotent?
Pluripotent.
These stem cells?
Absolutely. They follow instructions. Now, what's even more crazy, and I read about this, it's so stunning to me how powerful they are. And by the way, even though it's not ready for prime time, it's still in clinical trials, I can tell you I've seen patients who have responded to this with really end-stage heart disease. It's so crazy to see how powerful this can be from a single patient effectiveness perspective. Now, I read about this in a book because it's a case that this was like a mic drop moment, like how powerful this is. There was a young man in his 30s who fell off a ladder, broke his neck, became a quadriplegic, couldn't move his arms or legs, okay, who then volunteered for a clinical trial, had his fat liposuctioned, they removed the stem cells, and his neurologist injected the stem cells from his fat into his spinal cord, and it grew new spinal cord, and before long he began to move his arms and legs again. Unfriggin' believable.
That is just astounding. Of course, because we associate pluripotent stem cells with embryonic cells. Obviously, when we're in utero, we have to start from somewhere, and we have to make all these different organs, etc. And then there's but then that's tied up with a lot of ethical debate because you're using embryonic cells from fetuses that might have been aborted, and that becomes a whole political thing.
Mm-hmm.
And then there's Yamanaka factor, which can essentially, take stem cells and, through the introduction of certain proteins, et cetera. I'm not totally, that's above my pay grade, but essentially you can turn a cell into a pluripotent stem cell, a regular stem cell. But what I think you're getting at is that there's another way at this potentially,
Yeah.
which is extracting stem cells from fat, which is just like,
Well, and the reason
incredible.
the reason that's a setup to answer your question about like how can we actually convert fat, or how do we make more brown fat, is that the stem cells in your fat are so powerful, as we've just talked about, that when they're in fat, they can quickly copy paste and make another fuel tank, which is more white fat for storing energy when we eat. All right, but at the same time, there are certain foods that you can eat. Give you a good example: brassica foods. Broccoli, bok choy, cauliflower, those kinds of sulforaphane-containing foods that can take fat stem cells and nudge them so that they start growing more brown fat. Instead of becoming white fat, they're like, hey, dude, time for you to make a little more brown over here. All right? And so then instead of making more harmful fat, it makes more beneficial fat. Even more, other foods can begin nudging white fat cells to say, you know what? This is kind of like deprogramming you from a cult. They're sort of like, hey, you know what? I think you need to come back to, where we want you to be to participate in society. And so basically your white fat can be deprogrammed by certain foods. Nuts, tree nuts, for example, is one of those things. Tomatoes, lycopene can actually also do this. It deprograms your fat. Your white fat goes, who am I? And some of these food substances say, it's kind of like, it sort of convinces the white fat to start to go brown. Now, there's a color, if you're into graphic design or anything about color, in that color wheel, there's a color between white and brown, and it's beige. And so there's white fat, there's brown fat, and then there's the fat that's kind of like been coaxed over to the good side, and they start to turn beige. And beige fat cells can also burn energy. They can undergo thermogenesis, not quite as powerfully as the full-on brown fat. They got some mitochondria. It's got some iron in it, so that's why they've got a little tint, hue in their skin tone. But actually, the brown fat's got a lot of it. So you've got like the super engine, super space heater. You got the handheld portable space heater, the beige, and then you've got the white fat, which basically sits around and is jiggly.
Yeah. and then this is to say nothing of like your brain and DHA and myelin and how we again tend to villainize fat, but I think you've done a great job at setting this table of like, okay, we have beneficial fat, we have harmful fat, and what we need to do is find a proper balance in our bodies, between these fats for greater health. Because, the book does a great job of associating the mechanisms or explaining the mechanisms that outline the associations between fat or visceral fat, excessive visceral fat, and inflammation, and even COVID mortality and hospitalization prevalence, cardiovascular disease, diabetes. So there's really every reason in the world, if you care about your health, to be concerned with the accumulation of excess visceral fat. So one of the other myths that you debunk in the book, which I found to be very interesting and honestly very relevant to my own personal journey, was for the first 49 years of my life, I used to say things like, well, I was just born with a slow metabolism. That was just kind of the hand that I was dealt by the dealer of life. And now, I'm going to have to go through, all of these excess, starving myself and working out, 2 hours a day and all of this kind of stuff to try to combat my genetic code. Is there any validity to this claim?
Yeah, well, look, this is the other mic drop in my book, which is the new science of human metabolism, and it is so new that I can tell you it's less than 24 months old. So that's how it's like smoking new science. So 2 years ago, a landmark paper was published in the journal Science, which is the discovery journal for true science. It's one of the top scientific journals in the world. Very hard for anything other than landmark discoveries to be published in. And and this study, by the way, which I'm going to tell you about, pretty much upended and changed everything we know about human metabolism, including the assumption that your genetics dictate your fate based on metabolism. And here's what they did. There were 90 scientists that got together as a team. 90. That's a lot of people. And they all came from 20 different countries, and they studied 6,000 people. They studied the metabolism of 6,000 people using the exact same technique. Here's what they did. They gave them a little drink of water, H2O, all right? H in water is hydrogen. O is oxygen, so H2O. What they did is the researchers they tweaked the hydrogen, they tweaked the oxygen so you can measure it. You can and the measurement, once you drank the water, if you measured it in your breath, it would give you a readout of your metabolism, what happened to the hydrogen, what happened to the oxygen. You can measure it in your blood, you can measure it in your urine, your pee. Okay, so they measured 6,000 people using the exact same method, unprecedented, largest study of human metabolism ever attempted to be undertaken. And what they did, and this was a super surprising thing, they studied in that 6,000 group people that were 2 days old, newborns, all the way to 90 years old. So that's the entire lifespan, the human lifespan. And they wanted to ask, using the exact same technique, what was human metabolism? So what do you think they found? Their results, when they did the results, they looked at everyone's metabolism. It's just as you expect. It's all over the map, everywhere. All right, and not surprising, right? That's what you see when you look around, you talk to people. However, we live now at a time where we can do supercomputing and we can develop incredibly sophisticated algorithms and pull out data. And so what they did, this research team developed an algorithm in which they could put the data of everyone's metabolism, every one of the 6,000, through this algorithm to remove the effect of excess body fat. So meaning that if you're a little baby and here's your size, you could remove out the effect of excess body fat to see what the metabolism is. If you were middle-aged and you were overweight, they could remove the effect of excess body fat. If you're elderly and thin, they could actually, correct for that to figure out what the metabolism should be. And when they did that, it was like pulling the cloak off of the statue of David. They found that human beings across the entire lifespan have only 4 phases of metabolism, and everyone goes through them in exactly the same way. That's our hardwiring. And the first stage of metabolism is when we're born. We are all born with the same metabolism. And the moment we're out of our mom's womb, our metabolism skyrockets for the first year. So stage 1 is really the first year of life, and we rocket up to 50% higher than our adult metabolism is gonna be. All right, so that's stage 1. Stage 2, from 1 year old to 20 years old, okay, our metabolism goes down. Now, why is that a surprise? Because anybody who has kids will know that when your teenagers are eating 2 dinners and bouncing off the walls and sprouting up, right? Like you're like, oh man, their metabolism is going crazy, right? Wrong. It is actually slowing down to adult size. They're getting bigger. They're getting more mass, but their metabolism, their hardwired metabolism, is actually slowing down. Getting to cruising altitude where you're going to be, that's phase 2. Here's the real surprise. From age 20 to age 60, they discovered that human metabolism from age 20 is exactly the same 30, 40, 50, 60. It's a flat line. Our metabolism is hardwired not to change as human beings from 20 to 60. This means through your birth of your first child, through a divorce, through menopause, in your 40s and 50s and 60s, just because you're middle-aged doesn't mean that your metabolism is going to change, you're going to gain more weight. it is hardwired to be exactly stable. What this means is profound. It means that 60 can be the new 20 if you allow your metabolism to do its thing. Now I'm going to come back to that. Like, so why do people's metabolism change? That's stage 3. Stage 4 is a final stage. From 60 to 90, your metabolism decreases about 17%. Not that much. Okay, so that means that when you're 90 years old, your metabolism is only 17% of what it was when you were 20. All right. This is so new, so profound, that all the old textbooks of human metabolism are being ripped up and thrown out, and the new books haven't even been written yet. They're being written right now. So this is like, so what we're talking about is really a profound conceptualization of how the human body works. Now, so why do people have different metabolisms, right? Why do people actually curse their metabolism and blame their genetics? It's because when in this research, they added back the effect of excess body fat. Put it back. You crush your metabolism. You crush your hardwired metabolism. So what that means is it's not that a slow metabolism that you're born with causes you to grow body fat and gain weight. It's the other way around. Excess body fat and gaining weight crushes your metabolism. It's the other way around completely. And what that means is that the power of allowing our inner hardwired metabolism to resurrect itself, to fly, lies in our hands to be able to control excess body fat. We can't change our genetics, but we can actually manipulate excess body fat.
That is just a game changer, Will. I mean, and in some ways, I kind of when I try to classify this era that we're in medical science, I think about it as sort of the end of genetic determinism, where all of these new efflorescent emerging fields of science around metabolism, but also neuroplasticity and epigenetics and the microbiome is actually saying, no, we're not fixed. Our fates are not fixed, by our genes. Yes, genes can predispose us for certain things, and there's certain, single nucleotide polymorphisms or whatever mutations that can give us more proclivities towards developing this or that. But in a way, it's sort of doing what Einstein and Bohr and Planck did to Newtonian physics. It's just upending the whole thing, and it's saying, like, we are in this age of agency where if you begin to actually understand how the keys fit into the lock, you can upgrade, your human flourishing. And it's not just about the individual, it's about society. So this is just unreal, man.
Yeah, I mean, it really is mind-blowing. And the key thing is that, although biohacking is a very popular idea, the fact is that your body biohacks itself all the time. And the idea that you can eat to actually improve your metabolism, fight harmful body fat, allow your hardwired metabolism to rise to the surface. That means that, truly, the agency of our health when it comes to our metabolism is in our own hands. And so basically, now you start to understand exactly what happens during the 20 to 60-year-old age, right? Because even though our metabolism is hardwired to be rock stable, so many things happen to our lives. We have social stresses, financial stresses. We've got depression. We've got new jobs that actually make us couch potatoes. All kinds of things that happen to us in real life. We're inundated with marketing. We develop bad habits, and what winds up happening is that then we start to overeat, put poor quality fuel into our body. By the way, that back to the gas station and the car again. If you put good quality gas in your brand new car, your engine's going to run longer. If you put crappy quality gas in your engine, your car's going to run that day. It'll run the next day and the next day after that. But over time, you keep loading your car with poor quality gas, it's going to conk out your engine. It's not going to run so long. And so the quality of food really matters a lot.
Yeah, and I assume the foods that are the most obesogenic or that contribute most to the development of excess visceral fat are the ones that we kind of know, right? They're like trans fats in fried food and seed oils, refined sugars and refined grains and starches, ultra processed foods. Are there any other categories that you would lump in there?
Yeah, well, let me kind of paint the picture first. The foods that actually help us grow extra body fat happen to be the foods that are easy to overconsume. Either they're engineered that way from a marketing perspective to stimulate our brain to be addicted to the food, or that we're naturally just sort of overeat them anyway, like we're influenced by the marketing or by society to be able to eat those things. But it turns out that, ultra processed foods contain artificial preservatives, artificial coloring, artificial flavoring, additives. What do those things do? Well, we don't always absorb all those things for our own nutrition, but we pass down all those chemicals out of whatever's in that box or that bag, okay? We pass all that stuff down to our gut bacteria. And when we poison our gut microbiome, it's like pouring Drano or like into the water by the Great Barrier Reef. You're going to start burning and killing things right where it enters. And basically, when we start burning and killing our gut microbiome, all heck breaks loose. Inflammation starts to skyrocket. If you had some extra body fat that was getting inflamed because it was growing too big for its blood supply, now your gut microbiome isn't able to counter the inflammation. You've just poured gasoline onto that fire. Whoosh! Now you've got a raging forest fire. All right. You cut that gut microbiome. Now you've compromised your immune system, right? Now you're going to be much more vulnerable to disease. You've compromised your ability to heal. And that's why these nutrient light, they call the so-called empty calories, are really the counterpoint to the foods that do prevent us from actually gaining excess body fat. These are the nutrient-dense foods. Nutrient-dense is a term that, I only say it because people have heard about it, but it's almost a meaningless phrase. But what it really means is that there's a lot of, it's good fuel, high quality fuel. Not only does it have energy, but in addition to the energy, it has all kinds of other goodies for our body and our metabolism and our health defenses. One thing, often, in plant-based foods especially, you get dietary fiber. Now, not only are you getting good quality fuel, you are now also getting fiber to feed your gut microbiome. Your pets at home are very happy because you've given them really high quality food. They pay you back by actually lowering inflammation, helping your metabolism, lowering your blood lipids, and helping you heal faster and more optimally. All right. So fiber. What about the other really important category of bioactives? Bioactives are these natural chemicals. The lycopene, the sulforaphanes, the catechins, the flavonoids. You name them. There are thousands of these chemicals, and we're now beginning to pinpoint what does sulforaphane do to white fat. It makes it go beige. What does sulforaphane do to stem cells in fat, adipose stem cells? Makes them turn into brown fat instead of more white fat. What about lycopene? Similar. Chlorogenic acid in apples and pears and coffee. What do? They trigger thermogenesis. They turn on the space heater of brown fat. So now you can kind of see eating plant-based foods, okay? And when I say plant-based foods, whole plant-based foods, fruits, vegetables, nuts, seeds, legumes, healthy oils, the usual, right? I mean, this is not news. I'm not telling you the good stuff is we're beginning to, it's becoming second nature what's good food. What we're beginning to understand now is why the natural chemicals activate our metabolism, burn down harmful fat by activating good fat. And this is how you can eat to beat your diet, which is why I called my book Eat to Beat Your Diet. It's a trick title. Even though the word diet's on the cover, it's not a diet book. It is an anti-diet book because it shows you how this remarkable human body is engineered to be able to give us our optimal metabolism by eating the right foods.
Yeah, it's so great. And the way that you frame it in the book, I think is really just important for people because you can burn fat, get healthy, and still enjoy your life and enjoy food and actually eat it in some quantity. But it just really needs to be the right foods. And, you've put your thumb on fiber and on many of these, bioactives like quercetin and luteolin that essentially turn on your mitochondria, your energy factories in your cells that are prevalent in brown fat, as you mentioned. And then, you've identified 150 of these very, very potent foods that contain these bioactives and fiber and polyphenols, et cetera. And you've done so in a way where people can make the connections very easily. They can say, okay, quercetin, I get it. That helps really, jumpstart my mitochondria, for example. Well, where do I get that? Where I can get that in cherries and blueberries and blackberries, right? And you really do an amazing job there. And then you really set forth a program that is... it's not onerous at all. In fact, it can be just full of a tremendous amount of enjoyment while you're also getting healthy and feeling great. So can you just explain a little bit how you put together the program? And then I love the Mediterranean diet because I've never heard that proposed before. So maybe you can pull on that theme a little bit.
Yeah. Well, look, people always ask me, Dr. Lee, you study food as medicine. What kind of diet are you on? Like that's a typical question I get asked. And I always tell people, as I wrote in the introduction, I'm not into diets. I'm not into fad diets, crash diets, extreme diets. I'm really not into that because those things generally are about elimination. They don't work very well. You rebound off them, you yo-yo off of them, and it's really many times those diets are really about vanity, and I'm all about inner health. Now I do completely wholeheartedly support people. If you want to look good and you feel good, that's fantastic. But I, as a scientist and a doctor, I really wanted to work my research into inner health, which is about your metabolism and that hidden body fat and how to use it. Okay, so I tell people simply, I don't follow a diet, but I do have a way, an approach to eating. And I call that approach Mediterranean. And my background is Asian. I grew up eating Chinese food, and I love Asian food. And I actually lived during a gap year before I became a doctor. I lived in the Mediterranean. I lived in Greece. I lived in Italy. I literally walked the walk long before I started to talk the talk. And when I was in the Mediterranean, I was there to study the relationship between food, culture, and health. How did people kind of roll all these together into a natural, everyday a sense of self and identity? And of course, one of the things that you mentioned that is central to how I put my program together in Eat to Beat Your Diet is the word joy. Diets are not about joy, but food should be about joy. If you look at those really revered food cultures, culinary cultures, traditional foods out of the Mediterranean, which is, by the way, is like 20-some countries, all surrounding the Mediterranean Sea, not just Italy, Greece, and Spain. And then in Asia, there's 40-some countries. It's not just China, Japan, Thailand, Vietnamese, food. There's many, many different countries that are out there. It is really a kaleidoscope of know-how of selecting ingredients to put them together. And guess what? These ingredients happen to be the very same ones in both Mediterranean and Asian cultures that I write about in my book that activate your metabolism and they activate your health defenses. And so what I tell people is that how I eat naturally is Mediterranean. It's really either Mediterranean or Asian or some combination. I write about the science. And if you're interested in the science and you really want to kind of go deep, it's all there. All right. But if you really just want to know what you should be eating that's common sense and practical and absolutely delicious and can actually align your desire for having inner health and the enjoyment of food, you should try how I do it, which is Mediterranean, either way or in the middle. And you're gonna really enjoy every meal. Every meal you're gonna be talking about what you're eating. You're gonna be thinking about what you're eating. I don't know if you've ever gotten together with friends in either Italy, either in the Mediterranean or in Asia, but you know what they do in those countries? This is what I observed during my gap year. When they sit down, before they sit down, they're anticipating the deliciousness of what they're going to eat. In fact, indeed, they choose what they're going to eat based on what they feel like eating. They're looking forward to it. When they sit down as a family or as friends, people in the Mediterranean or in Asia, they talk about their food. They're talking about the seasonality, how it's prepared, how their mom made it, how amazing it actually is. And then when they leave their meal, they're grateful that they actually had such a delicious meal, and they know it did something good for them. All right, that's the long culture. And this whole idea of Mediterranean, by the way, sounds like a new concept. But what I read about my book, Eat to Beat Your Diet, is that, in fact, it's a 2,000-year-old tradition that was once connected, the Mediterranean and Asian, by the Silk Road, that 2,000 years ago stretched across the biggest continental mass and connected Asia with the Mediterranean. And back then, people on camelback, traders, exchanged recipes and ingredients and ate each other's food. And they really enjoyed themselves along the way and learned from other people. And that's what I want people who are reading my book to appreciate, is that there is a way of going back. Our future can be gleaned from looking back at the past, looking at how some of these incredibly delicious food cultures, traditional food cultures, brought their ingredients forward, assembled them together. If you're into the science, I put all the science there. If you're just interested in the history of the ingredient, by the way, I also talk about the history of all the ingredients just because it's interesting. Did you know that the pear actually came from Eurasia? It actually came from the Western China. That's kind of interesting. Do you know that carrots, which came from Southwest Asia, were originally purple on the outside and bright yellow on the inside? So again, there's so many fascinating things about foods that fight body fat and elevate our metabolism and therefore elevate our health while giving us joy.
Yeah, so great, man. I mean, I'm a little bit of a geek, so I like to know about ellagic acid and how it gets converted in the gut to urolithin A, and how urolithin A is connected to the mitochondria, and you can get that through walnuts and pomegranates. Like I'm into that, but I'm also super interested in the community component of food. Like you said, and you can really look at a lot of cultures and their different traditions, and borrow, respectfully from them. We have just a ritual around our house that I've mentioned before on the podcast called Rosebud Thorn, where we go around the table and we all talk about what our rose, our bud, and our thorn of our day was. And, what it does, it starts this kind of community interaction, and we move out of our sympathetic nervous system and this kind of like cortisol infused fight or flight mentality that the modern media culture is sort of creating, and we sort of come back here to this kind of parasympathetic state, and the blood kind of goes back into our gut, and you can actually start metabolism and digestion, like you say, before you even put anything in your mouth, because you can ready your body and upgrade it for proper digestion. Obviously, even enzymes start to, and digestive enzymes start to form, in saliva in your mouth before you even take a bite. So,
right.
This is a full picture, and you really, beautifully articulate the kind of the full picture, from the geekiness to the joy, in your new book. And I really just enjoyed every bit of it. It's so well crafted, well researched, it's insightful, and it's very, very practical, because, as you say, there's a lot of people that are just like, well, Dr. Lee, tell me what to eat, and I'll start adopting those protocols and matching them to my own bio-individuality. But I think, the message here that is, again, just so uplifting and empowering, is that we have so much agency over this notion of metabolism, and that's directly connected to longevity. And I don't necessarily mean living forever, but this idea of morbidity, compression, and matching our health span, these amount of years that we are thriving and feeling great and engaged and vibrant with our lifespan. And that has really run contrary to some of the trends that we've seen in the Western world, where, the last 16 years of our lives were, plagued by all of these chronic illnesses, and, we're on this kind of poly cocktail of pharmaceuticals. And, what we really want is a life that is full and thriving, and then, to compress that period of decline into the shortest period possible. And I think you've given us so many keys there.
Yeah, no, I mean, thank you for the opportunity to share this work with you. I'm really excited about it because not only is it really talking about the new science of the human body when it comes to metabolism, but it does actually set up a much deeper understanding of how to live long and prosper, as they used to say on Star Trek, the whole Spock saying, because that's actually that's exactly what we want, though, right? We want to live as long as we can be prosperous. And that prosperity is not just, it's not just the Benjamins. It's really like inner prosperity is a newfound appreciation, because chronic disease is not our destiny. I think our destiny is really hardwired into us. Like, our destiny is health. As long as we keep doing the right things and taking care of our car, going back to the car analogy, our engine's going to run for a long, long time. You need good quality fuel. You need to take care of all the parts of it. And by the way, it's not just what you eat. It's when you eat and how you eat. And not just eating, it also partnered up with movement and physical activity, and it's also partnered up with sleep and stress management. And so, I think that one of the things that I really try to do in my new book, Eat to Beat Your Diet, is really to deliver on that sort of bleeding edge science that everyone likes to hear about, that, when I'm involved, because that's what I do. I'm a scientist. But I also wanted to make sure that it really addressed all of these societal things that we've got to deal with. Our stress, are we getting enough sleep? Are we supposed to be exercising? And then when it comes to food, well, that is the medicine that we take 3 times a day. That is complete agency for us to be able to make those decisions. And you know what? Even if you skip a meal every now and then, that's absolutely okay. You're giving your body, our hardwire, our machinery, a little more chance to actually do that fuel burning. And that's why, by the way, I explain metabolism in simple terms that make sense to everyone, as opposed to going into the biochemistry of it, because even myself, I used to get confused when somebody was explaining metabolism to me when I was in medical school. I'm like, oh my God, it's like too much. I can't memorize everything. And now what I'm saying is that you don't need to. It turns out that discoveries teach us our metabolism is beautifully wired to run in that Goldilocks zone, as long as we really try to groom it and help it stay in that happy zone.
So good. Well, Dr. William Li, it's such a pleasure. Eat to beat your diet, burn fat, heal your metabolism, and live longer. Your newest pièce de résistance, as the French say. And this is coming out March 21st, 2023. But it will not be confined, I'm sure, to that time period. This is going to be a book that's going to influence a lot of people for a long time. And my guess is, given what a scientist you are and how committed you are to rigor and innovation, you'll probably be out another one before you know it. But I'll let you enjoy and bask in the glory of this one for a while. So thanks so much for being with me, and thanks again for all of your work and all the agency and empowerment that you're giving people around the world.
Thanks, Jeff. It's always a pleasure to speak with you.
Hey, thanks for watching. If you like this interview from the Commune podcast, then click subscribe and check out this video right here.